that I just mentioned, so you can use your cheat sheet 1 and 2. You will also be able to use the warm up that we're doing right now. Okay. So at the top here, this is something we kind of got to, but kind of didn't. And I don't want you to get it wrong because we just aren't there yet. So we've talked about that you have a rate of change is a slope. There are two types. Okay, instantaneous rate of change is the slope of the tangent line. And that's where you would take the derivative. Okay, so the f prime of x. Okay, an instantaneous rate of change would be the exact slope of the curve at that one x value. Okay, however, in all of your other math classes, you also covered what's called the average rate of change, which would just be your slope through 2 points. Okay, so that's the slope of the secant line. And you would do y2 minus y1 over x2 minus x1. Oh, yeah. You get your little warm up from over there. Okay, now, if you have a graph, the easier way to find slope would just be to calculate the rise over run. Okay, so for the example or the question that's like this on your test, it's a graph, just count the rise over run. But you could also do this formula if you want. Okay, so now let's take a look at a very similar question, okay, to what is on your exam. So it says, Janet goes on a jog. She records her position every 10 minutes as shown in the table above. Now, I pulled this question off Google, and it doesn't count by 10, so we just change it. This is now 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes. Okay, now, apparently Janet is, I don't know, as fast as can be because she did 12 miles in 20 minutes, but just pretend. Okay, it doesn't really make sense, but just pretend. Okay, so it says, calculate the average rate of change of her position over the first 20 minutes. Remember that average rate of change is just slope. So I'm going to calculate the slope for the first 20 minutes. That would be from 0 to 20. That'd be this line segment right here. And you should already know how to calculate slope. Pick 2 pretty points and then count the rise over run. So let's do that. Let's say I want to pick this pretty point and this pretty point. So these two right here. What would the rise be from here to here? 6. I'm going up 6 and then over how many? 10. Very good. So in question number 1, I want you to put rise over run equals 6 over 10. Now let's include units. 6 was the rise, which would be her position measured in miles. 10 would be her time, which is measured in minutes. So she ran 6 miles in 10 minutes, which we know makes no sense, but just pretend. Okay, you could reduce that. What would 6 over 10 reduce to as a fraction? 3 over 5 miles per minute. Okay, now, when you do that, okay, I want you to now look at the second question. So if they give you over the first 20 minutes, you would look at 0 to 20, calculate the rise over run. In the second question, it asks you to calculate the instantaneous rate of change at 40 minutes. So if I come over here to 40 and you draw in your tangent line, I just want you to notice something. Your tangent line perfectly matches the whole rest of the line. So if I don't have the equation for me to actually take the derivative, if it's a straight line, who cares? You can just calculate the slope, doing exactly what we just did. So if I want the steepness here at 40, then I'm just going to pick another pretty point and count it out. So let's find one more pretty point. Let's say we want this one and this one. Now notice you want to pick pretty points. You don't want to pick ones that are like in the middle, okay? So what would my rise be from here to here? How many do I have to go down? 6, and then over how many? This would be 10, 20, right? Because we're counting in tens on the x-axis. So my rise over run would be down 6 and over 20. Remember, we're counting miles on the y-axis, per minute on the x-axis. Will that reduce? Okay, what would that be? 3 over 10. Okay, miles per minute. Okay, now I want to point something out to you, that if it's a position graph and you found the slope, miles per minute is basically telling you how fast she's going. If you take the slope of a position graph, you now know how fast they were going. So down here for our little fill in the blanks, okay, it says if you have a position graph, it will be true that your average rate of change and your instantaneous rate of change are going to match each other. What I mean by that is that your rise over run is going to equal what your derivative is. And the reason why is because on a straight line, your slope is the same for the whole line segment. Okay, so just pick 2 pretty points, calculate your slope. Okay, then it says the rate of change, remember that just means slope. Okay, the slope of a position graph is your velocity or speed. So the steeper the graph, the faster that your girl is jogging. The flatter the graph, the slower that she would be jogging. Okay? So the question on your CIA gives you a position graph, asks you to find the speed. Now we know that means find the slope. Okay? Go ahead and turn over to the back side. All right. One other little question here. This is kind of a common sense question, but it's a little wordy, just like the one on your CIA. So it says, a hurricane off the coast of Florida is monitored, and the wind speed at various times in the formation of the hurricane are given by the continuous function W of t. So at 0 hours, your miles per hour for your wind was 74. Then it went to 80. Then it went to 82, 79, blah, blah, blah. Okay, it says, what is the minimum number of times that the wind speed must have hit 81 miles per hour? Okay, let's just count. If my wind speed of my hurricane went from 74 to 80, did it have to hit 81? No. What about when it went from 80 up to 82? Would it have had to hit 81 in the middle? Okay, so I'm going to put a check. We know it must have hit at least once. From 82 down to 79, must it have hit 81 miles per hour a second time? Yes. From 79 back up to 90, must it have hit a second time? Yes. What about from 79 down to 85? Or I said that wrong. From 90 down to 85. No. So how many times must it have hit 81? 3. Now let's just think about, how do I know that that's true? If my graph is continuous, then I know it's connected. It can't just leave a jump and skip any numbers. So every time you pass through 81, okay, basically you can count how many times that would happen, even if you don't have every number of every time for the hurricane. Okay, if that makes sense. Okay, last question. I forgot to put this on your cheat sheet, but I told you I'd let you have it. So remember that this means to take the derivative. Take derivative. And remember that this means take derivative and plug in x equals a. Okay, so let's just do 2 of them to warm up. Since we're about to take our CIA, we just had a nice weekend. We didn't hopefully think about math too much. Okay, look at the first question. It says f of x is 2 over x cubed plus 1 over x. Then what's the limit as h approaches 0 of blah, 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 lots of crap. Okay, you would say to yourself, I know that this means to do what? Take the derivative. Did I just take the derivative of that? Okay, it looks ugly, but you're not gonna find it the long way like we did in class. You're gonna use the rules that we've learned. Now, can I take the derivative of that as is? Or do I need to rewrite? Okay, how would I rewrite if x's are on the bottom? Do you remember? Negative exponents. Very good. That's right, Linus. So put rewrite. Any x's on the bottom have to get pulled up to the top using a negative exponent. So if it's 2 over x to the 3, how can I rewrite that? 2x to the negative 3. And what about the next term? What will that be? Okay, 2x to the negative 1. Is that correct? I knew you'd do that, but it is wrong. What did we do wrong? Where'd the 1 go? This was a 1 over 2, right? X to the negative 1. You can pull the x up, but you can't just make the 2 float to the top. That's a 1/2 in the front, so be careful on that, okay? Then from there, we're going to take your derivative. So what will the derivative be of 2x to the minus 3? I do negative 3 times 2. What do I get? X to the, very good. When I minus 1 from minus 3, I get negative 4 as my new power. Okay, next term, what's negative 1 times a half? Negative a half, and then x to what power if it was already a minus 1 and I minus 1 more? Negative 2. Okay, your answer choices won't leave your exponents as negative, so we just need to pop those x's down into the denominator. So this is going to be negative 6 over x to the 4 minus 1 over 2 x squared on the bottom. Okay. Questions on that? All right. Last one we're going to do together before we get started. Okay, I'm looking at my equation and it says that f of x is 2 tan x. And then they ask me for this crap. What do I say to myself? This means to do what? Take the derivative and then plug in what number? Pi over 3. Very good. So let's take the derivative. And then plug in pi thirds. Okay, because that's what my x is approaching in my limit. That tells me the number that I need to plug in. Now, to remind you, on your pink sheet, I gave you all of the trig derivatives. So will you pull out your pink sheet? Okay, and then on the front of it, you should have the derivative of tangent. Okay, can you tell me what it says? Okay, very good. The derivative of tan is secant squared. So if my function is a 2 tan, my derivative will be 2 secant squared. Write it down, please. Okay, f prime of x equals 2 secant squared x. Now, this would be the derivative at any x. I want the derivative at my x, which is what number? Pi thirds. So I'm going to write it like this. This is going to be f prime of pi thirds. 2 secant pi thirds squared. Now, I want to point out to you before we keep going. Okay, look on your pink sheet. Secant squared means the whole secant is squared. Will the 2 be squared? No, it's in the front, right? So make sure the reason I'm writing it like this is the derivative of tan is secant squared. That 2 is just in the front. It's not part of the squaring process. Okay, now look on your pink sheet over here to the side. Secant is which function flipped? Cosine flipped. So I'm going to find cosine and then flip it. So go to pi thirds on your hand. You have your little fingers here. Okay, pi thirds is here. Cosine's your top fingers. How many do you have? So it's 1/2. Now flip it. 2 over 1. Very good. Now, if you don't know how to do hand trick, I gave you the unit circle. Okay, pi thirds is right here. And then if you look at the top, remember, cosine is the x value. So if pi thirds is here, the x value is still 1/2. I still flip it. I still get 2. Okay, so from here, we have 2 over 1 squared, and then also times by 2. Okay, do I times these and then square? So 2 times 2 is 4, then square it? No, PEMDAS, we do the exponential first. Okay, 2 squared is 4 times the 2 in the front makes 8. Very good. Okay, you can do it. All right. So here's the plan for your CIA. Rather than having you do it on College Board AP Classroom today, I'm going to give you a printout of the exam, and you're going to start it today, and then you're going to finish it next class, and then put all your answers into College Board. Okay? So here it comes. You can do it. Please write your name on it very neatly so that I can get it back to you next class. It's 27 questions. Yeah. Yeah, you sheet of paper. Yeah. It's back here. It should say notes intro to rationals. Uh-huh. Oh, yeah. They're the same. Yeah, I think we do the hint sheet first and then we do the things. Oh, and then I forgot, there's one question they put on here that you should have a calculator to do, but obviously you can't use a calculator. So go to number 18. And I'm just gonna sketch the graph with you so that you know what the graph looks like, because you should have the graph for this question. But they made it a non-calculator test. So it's number 18. Okay, do you know what absolute value bars look like? Just tell me out loud. Yeah. What do they look like? A V, very good. And which way would the -2 move the V? Okay, very good. So draw me a little graph here. Go to the right 2. And then I want you to give me like a V shape. Okay, that's what the absolute value of X looks like. But it's not just the absolute value of X. What is that inside of? What symbol? So the square root is just gonna like bend your ends. So now it'll be like square root and square root. Okay, that's what your graph looks like. Okay, this is a cusp. Corners, same thing. Okay, so if you want to label, that should be a cusp at that point. Okay. All right, you have the rest of class. If you can't read anything, you can ask me about that. The only question people couldn't read in first period was number 9. It should say, oh no, wait, it wasn't 9. It was number 5. The top of that says x squared minus 4 over root x minus 2. X squared minus 4 over root x minus root 2. Okay. But if you can't read anything, just ask, and I'm happy to clarify on that. Also, I'm going to come pick up your CIA reviews. So if you don't have those out, can you pull them out?